Excuse me, sir.
Yes, go ahead.
Meeting is being recorded.
Sir, sir.
You are breaking up. I can't hardly hear what you're saying. Can you type?
Okay, so it's saying, hey, calculator, rotate, off, say 27.
Okay, guys, I can't hear what you are saying. But Rodney.
Madayer, wagwan. Sir, press the eraser or just press the arrow. Yeah, see it there? You that. You not even need me. You know see.
Guys, I'll ask you to mute your mic, all right, if you're going to talk to somebody. If not, I have to mute everybody. All right, now let's go now. The next one, right? How do I work out 4x squared times 3x to the 4th
Sorry,
power?
you cancel the x.
So what we do here, would I multiply the 3 times the 4, right? Which will give me 12, right? Then we have x squared times x to the 4th, right? X squared times x to the 4th. What you do, they have the same odds. You add them, so that will be x to the 6 divided by 6x to the third power.
Then cancel.
Now, 6 goes to 1 time, 6 goes to 2 times, right? Then what you let with 2x 6 minus 3. Right, because
so 2x3.
Right, so that's what give me 2x to the 3rd power.
Yeah.
Right, so that's how you'd have done the one with 4x squared times 3x to the 4th power divided by x, 6x to the 3rd power.
Sir, I never saw me do my own first.
No, but right, you could have used different way and you still get back the same result.
Sir, I cancel the 3, the x where they are the 3 and the one where they are the 6.
Okay, that's fine.
Yeah.
All right, now let's move to the next. Yes.
Which topic we are doing, sir?
We are just going through past paper questions.
Okay.
So, how you get the 4, sir?
Come again.
How you get the 4?
Which 4?
4x squared times 3.
No,
3x.
but no, look at the question. It's right here.
It is the question.
All right. Can we continue?
Yes, sir.
All right, let's go now. Solve the inequality, right? X minus 3 less than 3x plus 1. Yes, wonderful.
Sir, please unmute your mic.
Okay. Can you hear me?
Yes, sir.
Okay, so let's look at this one. X minus 3 less than 3x minus 7. What will I do? So I have x minus 3, right? Less than 3x minus
Sir, would you
7.
turn the less than sign into an equal sign?
No, not right now. We have to group them first, right? So first,
Sorry, yeah, come.
so we are going to move,
You move a 3 and put it behind the less than sign.
right? So I've been x minus 3x, right?
Minus.
Less than, right?
Yes,
Negative
oh.
7. Then this is what? This one is what? Negative 3. We move it
Since
to
the
the sense of
positive 3,
positive 3, right? So this give me negative 2x, right?
and it
Less
gives a
than
negative
negative
4.
4. All right. Then what we are going to do next, we will have to find the value of x. So how do I find the value of x? How do I move this 2 here, which is actually multiplying, to come over this side, right? But now,
Which is positive.
now, so
But
when
it is at some of them.
now
Negative.
watch this now. Whenever you are dividing by a negative number, right? Whenever you are going to divide by a negative number, you need
Yes,
to change the
positive.
inequality sign.
Make it
So
stay the same.
this would be x, right? Greater than negative 4 divided by negative 2. I repeat, whenever you are dividing by a negative number, you change the inequality sign, right? So this will give me x. Now the negative and negative cancel, be 4/2, so be x greater than 2 as my answer. Everybody catch that?
Yes,
Sir,
sir.
could you
Yes,
go
sir.
over it, please?
Sure. So we have x minus 3 less than 3x minus 7, right? So you move this 3 over the other side now. This is positive 3. If it's positive 3, you move it to the other side, it becomes negative 3. Negative 3x, right? Then this 3 now was negative 3. You move it to the other side, it becomes positive 3. But negative 7 will remain where it is. So 1x minus 3x. 1x minus 3x will give me negative 2x. Are you see that? And negative 4 plus 3 will give me negative 4. Follow that? Now, when you finish now, you want to divide by negative. You want to go and divide by what? Negative 4. So negative 2. Once you are dividing, you have to change the inequality sign. So it'll be negative 4 divided by negative 2. So negative and negative what? Cancel. So get x greater than 2. So you do it just like you are doing normal solving equation, right? But you treat the only thing different here is this: when we are going to divide by negative number, the inequality sign have to change.
Sir, but I don't understand how you get the negative 2x.
Because 1x minus 3x. What is 1 minus 3?
2.
No, 1 minus 3 is not 2.
Negative 2.
Negative 2. Thank you. So that's how you got the negative 2. You get it now?
Yes.
Now, then they ask if x is an integer, right? Determine the smallest value of x. That satisfies the inequality. If x is an integer, determine the smallest value of x. We satisfy the inequality. So if we have the normal line like this, and we draw the line, this is 0. Then here we have 1, 2, and what? 3.
3.
Right? And here we have what? Negative 1, negative 2. Now, so we go to what we need is 2. We go to 2.
2. And then you draw it.
The line going this way, right?
Yeah.
Now, so if you have, then here that be what? 4, right? So tell me something now, right? If I draw the line like this, right? With the line going straight, going this way here, what will be the smallest value? They say determine the smallest value. That's such an inequality. After 1, after 2, what will be the smallest value?
1.
No, go in this direction.
3.
3. So the smallest value would have been what? 3. Right. The smallest value here would have been 3. Because they ask you, if x is an integer, determine the smallest value that satisfies the inequality. So if you draw the normal line and you check at the 2, you realize that the smallest number here. So it would be 3, 4, 5, 6, 7. The smallest number that be 3. So here we say x is equal to 3. All right. Cool. Now, so let's continue. Right. We have a whole lot of
Wait,
things.
sir, wait, hold on, sir. Can you over that, please?
When you are here, right, you draw the normal line. The normal line, they say x greater than 2. When x is greater than 2, you draw a circle on the 2. You don't shade inside. The only way you shade is when you have the equal sign. So you draw a circle like this and the arrow going this. No. You want to find an integer which is smallest, but that's not an equality. So here you have 3, 4, 5, 6, 7, 8, 9, 10 continuous. Which one is the smallest number? What would have been the smallest number?
3.
Okay. All right. So as I tell you, we don't have much time, so we have to move try and see as much as we can cover. All right. Okay. Trig ratio. So at least everybody here have to know a little bit about trigonometry ratio, right? When to use sine, cosine, tangent, and when to use Pythagoras theorem. Because you might get a question which have to do with trigonometry ratio, right? Not necessarily exactly like this. I can get something like that, right? So
Sir.
what do we do? Yeah.
Sorry, can you go back for a second, please? You can continue.
All right. So guys, how do I do this? They want to define the value of x. How do I find the value of x? What will I do?
Sir, I use half this times I.
Look at it carefully.
Sorry,
Oh, Pythagoras theorem. Sorry.
We use the Pythagoras theorem. Now, when do we use the Pythagoras theorem?
When you have two
When you have
sides,
two
find the
sides,
third side.
Right, we use the Pythagoras theorem when we have two sides, one for the third side, all right? So in this case here, we can name here C, right? And we can name here A, and we can name here what? B. So I'm going to work it here now. I'll say C square is equal to A square plus B square. Wherever I have C, I put A square is equal to the small side, which would have been C
6
square plus 1, 8
8
square.
square.
Right, so x square, we work at what is C square?
36.
36 plus 8 square,
64.
64. So x square is equal to 36 plus 64. What do we get?
100.
100, right? So x is equal to square root of 100.
10.
Right, which give me what? 10. All right.
10.
So just have an open mind that you could get something different from this, but you might still have to go and find a short side, and you still have to apply the Pythagoras theorem, right? Then we could also be asked to find an angle, right? So if I want to find an angle right here, right, then I have to use this side, right? So what we do, we label the sides, right?
Hypotenuse.
So if the angle is here, what do I call this side?
Sine.
Opposite.
Opposite, yes. What do I call this side?
Hypotenuse.
What do I call this side?
Adjacent.
All right. So for me to do that, now, which formula am I going to use to find the
Sine.
angle?
Sine.
Sine. How do you know that is sine?
Because them give the opposite and the hypotenuse.
They give the opposite and the hypotenuse. So it have been sine. Okay, so it be sine, right? Theta is equal to opposite over hypotenuse. So sine theta, right? My opposite would have been 6 over 12, right? So sine theta, right? 6 over 12, what do I get?
Half.
I get half, right? So theta is equal to sine inverse of 0.5, right? So theta, now what is sine inverse of 0.5?
30.
You get 30, so that would be 30 what?
Is
30 degrees. You have that?
Yes, sir.
Okay, moving on. So most
Yes, sir.
likely,
Can go back. Can go back,
sure.
please.
All right. So let's go. Okay. So here now, we could be giving a statistics question where they give you the raw data, right? You fill out the table, then you have to calculate. You fill out the table, they ask you the questions, or maybe you have to calculate the mean. I don't know, but let's see. So if you are giving something like this, what will I do? 20
Tally
30
from
bags
1
of
to
sugar.
10.
We tally. So how do I tally? 1 to 10. How many? What do we get from 1 to 10?
Three of them.
Three.
So
Three.
1, right? 2,
Three.
And 5.
and where's 5? You see
You done
5?
mark it already, sir.
Sorry, market, sir.
Oh, okay. So that
Three,
what?
sir.
1, 2, 3. I put here what? 3. Now the next one.
11,
12, 17,
So it'll be 1,
18,
1, 2,
4.
3,
4,
3,
4 would have been.
and 18.
The
3,
18 there right after.
4.
4.
So I have
So
4.
that's
1,
4.
2, 3, 4. Then what? 4. Okay, 21 to 30.
The 22 and the
1,
23 and the
2,
28 and
3,
26.
Of
So
them.
that be this one.
1,
1, 2,
23,
3,
25,
4,
4,
5. The
5.
30.
5, sir. The 30.
at the
30.
30,
Where's the 30?
at the
Over.
last
Below the
number.
28.
Above the 26.
Oh yeah. Okay. All right. So 5.
So
1,
5.
2, 3, 4, 5. Then 5. Okay. How many 31 to 40?
1, 2,
6.
6.
6 of them.
All right. So we have 1, 2, 3, 4, 5, and what? 6. 6. How many? 41 to 50.
2 of them, sir.
Sir,
2,
2.
2.
All right. So they ask the question here, right? We should find the upper. Oh. Okay. So I missed something here which I should have put, right? For the class 21 to 30, right?
0.5.
Now, if I have a class 21 to 30, I want you to tell me the upper class boundary for this class.
30.5.
Should have been 30.5.
35.
Should have been 30.5. Thank you. Now, I want you to tell me the class width for this class. How do I find the class width?
Yeah, add up.
Anybody remember how to
The
find class?
the upper class subtracted by the lower class.
So the class width, right, would have been the upper class boundary,
20.
upper class boundary minus the lower class boundary. Right? Everybody get that?
Same 21 to 30.
No, so it had been the upper boundary would have been 30.5. We have 30.5, right? But the lower boundary, how do we find the lower boundary for this?
So subtract
20.5.
20.5.
So that would be 20.5. Right. So when we work it out, what do we get?
10.
We get 10. All right. Let's
How did you get the 20.5, sir?
you minus 0.5
Excuse me,
from
sir.
the 21.
Hold on, sir. Hold on, sir. 30.5 at the upper quartile.
Because they add 0.5 to 30. That makes it 30.5.
And that's 6 at the highest tally.
Something like the same.
So if between 31 and 40 have the most number of flags.
Okay.
Sir, your mic is muted.
Can the person, somebody's television is on. Can you lower it a little bit? Thank you. All right. So if you want to find the upper boundary, remember, if you want to find the upper boundary, you go to the upper number and add 0.5. If you want to find the lower boundary, you go to the lower number, you minus 0.5. If they ask you for class width interval, you go to the upper boundary minus the lower boundary, which will be 30.5 minus 20.5, then you get 10. All right. Now they ask for a class midpoint. How do you find a class midpoint for 21 to 30? What do I do?
Add it and divide it by 2.
You add it and divide by all 2, right? So we are going to add what? We are going to add 21 plus what? 30, then divide by 2, right? Which give me what? 51, am I right?
Yes, sir.
Divide by 2, what do I get?
25.5.
20?
5.5.
25. Give me a minute, guy. So this would have been the histogram, right? Now, just also remember that they could give you cumulative frequency curve. They can give you frequency polygon. Any of these three will play. Histogram, frequency polygon, or cumulative frequency, one of them, right? So
Yes, sir.
I'm saying that a cumulative frequency, histogram, or frequency polygon, one of them will come tomorrow. Which one, I'm not sure. But I'm just going with this, right? Because of the boundaries, how to do that. Cool. All right. Can I move on now?
Yes, sir.
So I clear everything now. I'm moving on. I have a whole lot of things I want to. Okay. A straight line passes through the point T, 4 and 1, and has the gradient 3 and 4. Determine the equation of this line. What will I do?
Use the gradient formula.
Right, which is what? No, but they gave me the gradients and they asked me to write the equation of the line. What will I do?
Sir, you would
Sir,
use
y
the
equal
MX plus C.
use the y equal mx plus c.
So it say y is equal to what? Mx plus c. Thank you. So we use the formula y is equal to mx plus c, right? So we use the formula y is equal to mx plus c, right? So here now, what we do here is this. You'd have established that t is actually 4 and 1, and m is what? 3/5. This one represents x, this represents y, all right? And you want to find, write the equation. So first of all, you're going to find c, which is the y-intercept. So you say y is equal to mx plus c. Wherever we have y, we put 1. Wherever we have m, we put 3/5. Wherever we have x, we put 4 plus c. So when I work out this, I get 1 is equal to 3 times, this give me 12/5 plus c, right? Now, what do I do next? How do I find C from here?
So you have
That's
carried the 12 over 5 by Monday.
We carry
Alright.
over, right? So it'll be 1 minus 12 over 5 is equal to C. So put this on 1, then we find the LCM. My LCM would have been 5. 1 go to 5 will give me 5 times. So 5, 1 will give me 5. Minus 5 going to this will give me 1 time. So work out this to get 12 is equal to C. Now when you work it out, 5 minus 7, sorry, 5 minus 12, what do I get?
-7.
-7
So -7 over 5
over 5.
is equal to C. Now, when you finish now, I'm going to put, you put M
And
and
C in the
C,
equation.
C in the equation, right? In the equation. So that means my M is 2 over 5. My C is equal to -7 over 5. So I say Y is equal to 3 over 5x, right? Plus -7 over 5. If you want to write it neatly, it would have been Y is equal to 3 over 5x minus 7 over 5. We get that?
Yes, sir.
Right, so by now everybody should feel comfortable at least writing the words equation of a straight line, right? Because something you can escape tomorrow. Tomorrow you are going to get something like that, all right? So you have to know either directly or indirectly, right? You have to go and deal with some form of equation of a line. So this is the simplest one you can get, right? But they can also give you like this. Everybody can see my screen?
Yes, sir.
Now, sometimes they'll give you this one here, right? And they
Sir, you
ask,
can go back.
Sir, can go out, please.
I should go back.
Yeah.
Okay, all right, cool. Wait, I'm coming. Okay, there we go.
Thanks, sir. You can go.
All right, cool. Now, what about sometimes they give us the equation of, and they want me to rewrite it in the form of y is equal to ms plus c. How do I approach such a question? What will I do?
Sir, I put y equal mx plus c.
So we put y is equal to ms plus c. Okay, y is equal to mx plus c. Yes.
-4y
Negative 4y
is equal to 3x plus 5.
plus 5. Something missing. Something. Anybody can pick up the error. There is some slight error right here.
So would it be
Seven.
negative
The error is the
3x?
same.
Negative
Seven,
3x, right? Negative 3x, because you move, remember, no, you move the 3 over the equal sign, right? So the fact that you move the 3 over the equal sign have to become what? Negative, all right? But we still not yet finished because we want to make y to be the subject, right? We want the y to stand by itself,
Second put over -4.
right? So that means, so I would say, look, I would say -4 over -4 is equal to
So we
negative
divide
3.
everything by -4?
Exactly, that's what we are doing now.
Well, -4.
Now, so -4 cancel the -4, right? That's why.
Right.
So what is left? Negative and negative will cancel here, am I right? So
Yes,
basically what will be left
Excuse
here,
me, sir.
y equal
y equals to, yes, go ahead.
3x
Wait. 3
Sir, no
over
last
4
me right. No
minus,
last me up the saying, sir.
okay, all right. So look at what happened. You want to rewrite the equation, right? Look at what they say. Look at what they say. Write in the form of y is equal to what? Mx plus c. Are you seeing that? Yes. Hold on. So what you have to do is the same. You have to make the y, just move, you are moving everything. This is the equation. So you move the 3 over the other side, which become negative 3x, but the y will, this negative 4 will remain. Do you see that?
Oh, yes, sir. Yes, sir.
So the negative 4 will remain, then the 3 will go over. It was positive, it turns negative. Now remember that you want to follow this same format, right? You want to make sure that you follow this same format. That's the main idea, right? Then the 5 is positive, so be positive 5. Then later get rid of the 4 now. The 4 is multiplying. You divide everything by what? Negative 4. You get that?
Yes, sir.
Okay, good.
Sir, or you get the negative for the denominator.
No, because I'm getting rid of this 4 here. So for me to achieve that, I divide everything by negative 4. Just like remember, if I have 2x, it's equal to 8, and I want to get rid of the 2, I say 2x over 2, then 8 over 2, just to get rid of the 2. So it's the same principle.
Sir,
Yeah.
question, sir. How did the fraction on the x become separate from the x, sir? Like I see that you have 3x and then you put 4 under it, right? But then on the next part of the equation, they say y equal 3x, 3 over 4x. How did that happen?
It's the same thing. It's the same thing. I was just, because if I have 2x over 5, right? It is the same thing as 2 over 5x. Because at the end of the day, you can multiply the 2 times the x, you get 2x over 5. Am I right? Now, because of the idea too, I want to get the m by itself. I want to separate and get this. I want to separate this one alone. Are you seeing that? And this one alone used to be your c. Because the next question, they asked me to find a gradient and I have to separate it by the same thing. Have I answered your question?
Yes, sir.
Good. All right. So the next question they asked, right? The next question they asked, determine the gradient of the line. So they want to find a gradient of this line. What will I do?
You look, what is the m in the first equation? So
Which
the
will be
three
what?
over 4.
3
So
quarters.
Right, we are 3 over 4. Thank you. Now, the point P with the coordinates R and 2 lines on the line L, right? Determine the value of what? R. What will I do here?
Label.
Now, so here now, my advice here, if they give you something like this, right? And they say that you should determine, they say that the point P with the coordinates R, lines on the line, right? Determine the value of R. So so imagine that this is a graph, right? And we draw the line like this, coming this way, right? The line, this point P lines on this same line, and they say that you should find what's the coordinate of this line here. So in other words, what you have to do, write back the equation which you have, which is 3x minus 4y is equal to 5, right? Now, you remember that you have been given R and what? 2. So this one represents your x, and this one represents the y. Everybody see that? This one represents the x, and this represents the what? Y. You are going to substitute the x for R, and you are going to substitute the 2 for y. So when I come here, I'm going to say 3R minus 4 times 2 is equal to 5. See if you see through it. Everybody see through it?
Yes, sir.
Yes, sir.
Okay. Now, after that now, you are going to say 3R minus 8 is equal to 5.
Equal 5.
Right. And you want to find the value of R, right? So I'm going to say that 3R equals 5 plus 8. So 3R is equal to 13. All right.
And then you carry over the 3.
R is equal to
gonna
13
divide.
by 3.
Yeah.
By
Right.
3.
Which give me
4.333.
4.3333. Right. Are we clear? So we have this, right? Oops. I'm looking for eraser. Anybody can see the last question?
Yes,
No,
sir.
sir.
What are they asking?
Find the equation of the straight line passing through the point 60, which is perpendicular.
So they make mention that it's what? Perpendicular, right? It's,
So,
yes.
Professor, so the formula for that is 1 over m something.
All right. So what will I do here? When two gradients, when two lines are perpendicular, right? What happens to their gradients? Anybody remember?
So it's -1.
-1. So when you multiply the first gradients, right? So when you multiply the first gradients, m1 times m2, I should get -1. Follow me up, right? So our m1, our original m1 is actually 3/4. If I want to find m2, what will I do?
The inverse.
Right. We turn it upside down, right? We turn this one upside down. We put
-4/3.
right. It'll be -4/3. So when they say perpendicular, once they use the word perpendicular, you look for the first gradient, whatever it is now. Then you try as much as possible to put it. You reverse it, right? So I said that, let me just see, m1 times m2 should give me -1, right? So I say m1.
Sir, I'm not seeing the last question good, please.
Okay,
Can
no.
you-
No, I think, hold on. Right, then this m2 is equal to -4/3. Okay, I'll try and write, I'm going to write the last question here. So anybody who wants to, they say that they say find the equation of the straight line right? Passing through the point 60, which is perpendicular to L, which is perpendicular to L. So that was the question. So before we do anything, right? Before we do anything, we have to look for the perpendicular gradient, which is 3/4. They say should pass through 6 and 0. So now I'm going to write a new equation, right? for me to write the new equation, I'll say my M2 is equal to -4/3. And I should pass through 6 and 0. I name this one here X and name this one Y, right? I write Y is equal to MX plus C. So I'm going to find what is the value of C first. So my Y will be 0. My M will be -4/3. My X will be 6 plus
6
C.
and the Y and the
Now, so I'm going to work out now to find C. So 3 goes to 1 time, 2 goes to 2. So I get 0 is equal to -8 plus C. I want to find what is the value of C. So I move this 8 over this side.
Okay, but
0
over to
plus
0.
8 is equal to C. So C is equal to 8.
8.
All right. Now, when I finish now, I'm going to write the equation now. My M is equal to -4/3.
Could we use any of the gradients here to do this question?
No, you use the gradient they give you initially. Then you find the perpendicular gradient. So now I'm going to use the perpendicular gradient to answer this question now, because that's what they use, perpendicular to L.
Okay.
So my gradient here would have been 4/3, -4/3, and my C
Would have been
8.
8.
So if Y is equal to -4/3x plus 8 as my answer.
You want to see it?
So let's go one more time. So if they should bring coordinate geometry question tomorrow, most likely they are going to ask about perpendicular gradient, perpendicular line. Sometimes it has to do with what? Perpendicular line. Where we say M1 and times M2 is equal to 1. Or maybe they can prove, they ask you to prove that two lines are perpendicular. How do you prove that two lines are perpendicular? When the first gradient times the second gradient should give you -1. And when they say one line is perpendicular, now all what to do, flip the original one and put a negative sign. And that will give you a new gradient. And with the new gradient now, you use it to go and find the C and write the new equation. We follow through. Okay, so can I move on to the next stage?
Yes, sir.
All right, so let's go. Which one is this? Oh, transformation. All right, so everybody can see this question. Now, so tomorrow, there's going to be a transformation question. I don't know if it's going to be reflection, enlargement, rotation. Well, I have no clue, right? But at least you have to have an idea how to reflect, right? And how to do certain things, okay? So here, we're going to attempt to do this question here together. Using a scale of 1 centimeter to present 1 unit on both axes, draw triangle ABC, right, with A, 2 and 3, B, right. So first of all, if I'm giving something like this, I'll have to take my ruler, right? I'll take my ruler, right, and draw my line, right, here. Okay, so I need a little thicker. All right, so I'll come here, draw my line, right? Let me see if this one can work. I'm not sure. Then draw this one here. Right. Then on the graph paper they will give you. Now remember that thing. For graph work, you use pencil. I repeat, for graph work, you use what? Pencil. So yeah, we come here and we just label this one as 1, right?
Sir,
Yes.
can you put the y-axis over somewhere, sir, because there's a point that says -7
-7 where?
over at the bottom.
Oh, okay.
So
Thank
you'd
you.
have to shift it.
Okay, all right. Thank you, Ali. So I'm supposed to shift somewhere like this. Can I get a 7 now? 1, 2, 3, 4, 5, 6. Yeah, I can get a 7. Thanks.
Excuse me, sir. For the
Yes.
other questions, they only make mention of being written in pen, so the others must be done in pen.
Okay. So what would have happened here is this: you only allowed to use pencil for any graph work or construction work. Everything else have to be in pen. You use pencil for graph work or construction. Apart from that, every single thing you're going to do have to be in pen. Reason being is this: they are going to scan your work, right? They will scan the work for markers to mark. If they scan in pencil, they can't see what you wrote, and that can be disadvantage for you. But when they are scanning the graph works, they have special effects they use for the graph ones or the construction, so you can pick it up easily. But for the normal writing, they have no special effects for photocopying. So ensure that all your working, you use pen, right, to save yourself. Everyone understand that? For paper 2, paper 1 now, paper 1, that's only where you only use pencil to shade alone. We clear?
Yes, sir.
Okay, so let's go now. I need to plot the points here, right? So this one would have been 1, 2, 3, 4, 5, 6, 7. 1, 2.
But sir, another thing to say, shouldn't it be on the same side for the y-axis, the negative and positive?
Come again.
That the numbers on the y-axis shouldn't be in the same direction or position.
Position on the Y, it doesn't really matter.
Okay.
That's the least of the problem. The most important thing, ensure that okay, some people will tell you that it always have to be on the left hand side, or have to be on the right hand side. To me, it doesn't make any difference. The most important, you know what you are doing, and make sure that you put a negative sign. So whoever marking your paper know that, okay, this side you put a negative and this side is positive. You get that?
Yes.
Just ensure that the negative is there. So then the positive is there. That's good. Now let's go now. We are going to plot the points A, B, and C, right? So how do I plot the points A, B, and C? So A is what? 2 and 3. 3. So we come here, look for 2, 2 and 3. We plot the points, right? 2 and 3, right? Am I right? The next one, I name it A. The next one is what?
5 and 3.
5 and 3. I name it what? B. Then what? 3 and what? 3 and 6. I name it what? C. Then I will join these ones here, right? All right, so we have A, B, or C. Okay. Now, I am supposed, so that's the first part. for 3 marks. Everybody see that?
Yes, sir.
Now, the next question I was asked to draw a reflection line y is equal to 2. Now, how do I draw a reflection line y is equal to 2? What will I do?
Well, sir, so, the second question.
Second question, they say on the same axis, right? Draw and label the line y is equal to 2.
Sir, would you go to the 2 on the y-axis and draw a vertical line across?
Right, we go to 2. Sorry, we go to 2, right? As she said, right, and we draw a vertical. So we come here like this, go to 2, right? And we draw this. Everybody see that?
Yes, sir.
So in this line here, on this line here, we name it y is equal to what? Y is equal to 2. That will be my mirror line. So if that is my mirror line, right, I need to actually reflect. So how do we reflect here? What do I do? How do I reflect this over that side? What will I do?
You count up from the point to the mirror line.
We come from the point, right? Then what?
Then you go from that same point to the mirror line down to the same number,
Right.
the point.
Good. So what we are going to do here, right? This is we count the same thing here. So this one here would have been 0, 1, and 0, 1. So this point here, I name it A prime, right? 0, 1, 0, 1. There be what? B what? B prime.
B prime.
Then 0, 1, 2, 3, and what? 4. Everybody see that? 0, 1, 2, 3, 4. You can't say 0, 1, 2, 3, and what? 4. So right here, I name it what? C what?
C prime.
C prime. Then what we do?
Again, sir?
So you drop.
Come again.
Second this again?
Sure, no problem. So you can't, remember that the mirror line is y is equal to 2, right? So you count from the A to the mirror and the mirror to that side. So 0, 1, 0, 1, right? Then the C, 0, 1, 2, 3, and 4. 0, 1, 2, 3, and 4. So you always start counting from 0. Then the B, 0, 1, 0, and 1. You catch it now?
Yes, sir.
Then what you're going to do now, you join them, right? You join them now. You're going to join this with this. Join this with that. And join that with that.
Sir, why you stopped at 4?
Where I stop at 4? No, because that's the way the mirror, that's where the mirror stops.
Okay.
So 0, 1, 2, 3, and 4. You see the red line, the y is equal to 2 line. That's where it stops. Am I right? Then you count the same thing going down. 0, 1, 2, 3, and 4.
So we do the new one with the, what's it called? The double prime or the 2 prime?
Yeah, so right. So the new one that have been the double prime. Okay. So I'm not going to tell you lines. 2021, the questions they gave them, they tested them on reflection, translation, enlargement, and rotation. 4. 4 of them, they tested them on 2021. I don't know what they are going to test you guys tomorrow. But whatever be the case, at least reflection will appear in a way. Maybe translation also. I don't know. I can't do everything in this 90, so me just a pick. So let's hope for the best. At least something you guys can manage. All right. Let's see what I go on tomorrow. Next one now, they say I should draw a new triangle. Everybody see that?
Yes, sir.
Draw a new triangle, A double prime, B double prime, or C double prime. So I'll go to A double prime, -7 and what? 4.
4.
So this -7 and 4
No,
right
sir.
here.
Negative
Right here.
7, 4. Yeah.
That should have been A double prime. The other one is what? B double prime, -4 and what? 4.
Positive 4.
Then C double prime,
-6
Negative
and 7.
6 and 7.
-6 and 7.
7.
-6 and 7.
And 7.
Right. Then we join this one now, right?
Yes, sir.
Then they ask a question, right? So they said that the new triangle, name and describe a single transformation that maps ABC onto triangle A prime, A double prime, B double prime, and C double prime.
Sir, it is
Is it a reflection, rotation, enlargement, or rotation?
Is it a what?
I'm asking, is it translation, reflection, rotation, or enlargement?
Sir,
A translation.
It's a translation, right? It's a translation. Translation by what?
Which are congruent or something like that.
It's a translation, yes, of course. It's a translation, right?
Sir, how?
No, because it's slide. It can never be reflection. For reflection, they have to face each other, right? Now look at it. This is A, and this one here is a B. You realize that? So there's no way it can be reflection. Reflection, they have to face each other, and they have to be on the same level. Now, it can be rotation. Rotation, they have to turn around. And it can be enlargement. Enlargement, one have to be small, the other one have to be what? Big. So the only option we have here is translation. But every translation has the vector movement, right? Anybody know how to do the vector movement? How to go around it?
Sir, you divide the scale factor by the number.
No, that is you're going enlargement, man. We are talking of translation.
We can look at the movement of 1 point.
We can look at the movement at 1 point. Yes, we look at the movement 1 point. So we can start look at the A, right? Let's go to the A and count. Let's see. So let's go. So we move from the A, right? Let's count how many boxes up to this point and going up. So that means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be -9, and I go up 1. So it will be -9 and 1. Now let's try again. Let's try the B if it's the same thing. If it's translation, all of them have to have the same movement. I repeat, if it is a translation, all of them have to have the same words, movement, right? So let's go to the B. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and what? 1. So 9 and 1 is -9 and 1. So that is actually that. So what are we going to say? So we need to describe it fully now. Anybody know how to describe it fully? Anybody want to try?
Right.
How do you describe it? They say,
sir, ABC map.
okay, hold on. So triangle, I'm going to say triangle ABC, okay. Triangle ABC, right, is mapped.
Mapped onto A double prime.
Mapped to A double prime, B double prime, C double prime by what?
Via translation,
By translation, right?
which movements
With the vector,
there is vector,
right?
vector
Negative
sum of
9
9
and
and
1.
1.
And that's your that
So
will
you
give you the
get
full mark.
-9 and 1 again.
No, but if you put negative 9 and 1, you just have to make sure that you write that triangle ABC is mapped onto A double prime, B double prime, C double prime by translation with the vector negative 9 and 1.
So do you have to use the 9 or you can use any other point as well?
When you say the other point, what do you mean?
Does it use like supposed to use A or Z? A
No, you
or
can-
B to find
no,
it, or
You can use C. You
C?
can no. Once it's a translation, all of them will have the same movements, so it doesn't matter which one you use. So for me, what I do, I check all of them to make sure they are the same thing, just to make sure.
Yeah, but C to B will be negative 9 1. C to B double prime.
No,
C to B double prime. Right?
no, C to B.
B
No,
double
no,
prime.
no, no, no. You compare C to C, A to A, and B to B.
See, in this case is when we pay for it. Oh, sorry, sir.
All right. Now remember that you could also be given enlargement. So enlargement now, most of the time you have to go and find a scale factor. Maybe sometimes when you give it enlargement now, you have to find the center of enlargement. After you find the center of enlargement, then you find a scale factor. Right. So something
Sir,
you have to,
negative 9 and 1 come from again, sir.
because I moved from the A going to the A. I moved from here. Let me show you what I did. I moved this one here. Look, I moved this direction. You see that? I came from the A to the now. When I come to this direction, it will be negative. Then later I go up. So right. So when you go to the left, when you go to the left, it's negative, and when you go up, it's
positive.
right.
All right, sir.
Sure, no problem. All right, we're moving on. Can we move on?
Yes,
So,
sir.
Yes, sir.
Sir, hold on. Undo that, sir. Undo that. What up? All right, sir.
You get it?
Yes, sir. Want to be just, want to be some time look on it before we do the exam. No.
Okay, all right, no problem. All right, so I don't know what is next now. Let's see. Oh, anybody have any idea what is it? What is this one?
Map work.
Map work. Yeah.
Sure.
Yeah,
The
sometimes
librarian.
listen.
I get this? Sir, this really come.
You ask me don't know. But it's better you at least have an idea how to do it than not know it at all.
What's called map work?
We call it scale measurement. We call it scale measurement, right? But it appears now and then, right? It appears now and then. We call it scale measurement. But it's something simple you can pick up, no? Okay, let's look at this idea, right? Can somebody read the top for me?
The diagram below shows a map of an island drawn on a grid of 1 centimeter square.
Oh. You're bright here. You think I'm your mama?
Hello. All right, mute your mic, please. Okay, let's go. Go ahead, miss.
The map is drawn to a scale of 1 to 50,000.
Okay, so look at everybody. They say the map used is 1 to what? 50,000. Now, so in other words here, every 1 centimeter you measure on this map here is got to 50,000 centimeters, right? So what they are telling you is a clue that every look at it. They are saying that 1 centimeter on the map is equal to 50,000 centimeters on the ground. That is what it means. Everybody understand that?
Yes, sir.
So you have
Yes,
to just
sir.
understand the concept. Every 1 centimeter you measure is got to 50,000 centimeters on the world ground. Okay, let's go. What next now? What next now?
The first question, sir.
Yeah, so we have been given this. What they say now?
1 centimeter on the map represents 1 centimeter on the island.
Right. So what do you think we'll put on the first dash?
50,000.
50,000. Everybody say, so everybody get that? So here we are going to put off. Here we are going to put your 50,000. All right. So everybody understand that, right? Now,
Because
Yes,
one
sir.
now what's the next question?
An area of 1 centimeter square on the map represents an area of 1 centimeter square on the island.
Okay, so let me ask the question. If 1 centimeter is equal to 50,000, right? And then I want to find 1 centimeter square on the island, it's got to dash on the island. What will I write?
You're going to square the 50,000.
50,000
Right, so
times
we've
50,000.
squared the 50,000. Thank you. We squared the 50,000, right? So you can put 50,000 square, or you can put, so this number actually is 2, 5, then how many zeros? 8.
8 zeros.
1, 2, 3, 4, 5, 6, 7, 8. So 1 centimeter square on a map represents that figure. Okay, next question. Given that 1 kilometer is got, look at, they say, given that 1 kilometer is got what? 100 centimeters, right? A distance of 1 centimeter on a map represents dash centimeters, dash distance kilometers on the island. So what are they asking first? They asked me to convert this question. They asked us to convert the 50,000 centimeters to what?
To kilometers.
Kilometer, right?
Meter.
They asking us to convert from 50,000 centimeter to kilometer. How do I convert from 50,000 centimeter to kilometer? What do I do?
You divide.
You divide by what?
1.
Sir, by the 100,000.
By the 100,000, right? So we divide this one by 100,000. So this would
Sir.
be, yes.
They can do that one number 2.
Hold on. For number 2, hold on. Somebody asked me to. For number 2, they say an area of 1 centimeter square on the map represents that centimeter square on the what? Island. So if you look at it, look at the question. If they are saying that the area of 1 centimeter square, right, on the map is equal to that centimeter on the ground, every 1 centimeter will give me 50,000. So if I have 1 centimeter square, that will represent 50,000 centimeters square. So that means I have to square this one here, right? I need to square this one itself. So 50,000 times 50,000 will give you the figure we see here, right? Will give you the 2, 5, then the 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's go back to this question now. Given that one kilometer is equal to 100,000 centimeter, a distance of 1 centimeter on the map represents a distance of dash kilometer on the island, right? What do I do?
Sorry, divide.
We divide. So we divide what?
The 100,000 to the 50,000.
Right, so that means 50,000, right? So 50,000 divided by what? 100,000. So 50,000. 50,000 divided by 100,000, which give me what?
0.5
0.5 what?
kilometers on the island.
So this would be what? 0.5 what?
I don't get that here.
Okay, look at what they say now. 1 kilometer is equal to 1,000 centimeter, right? A distance of 1 centimeter on it. So they are telling that for every 1 kilometer represents 100,000, right? So they want you to find out the distance on the map in kilometer, the actual distance on the map in kilometer. So one centimeter will give us 50. Are you following? Centimeter. We don't want the answer in centimeter. We want the answer in what? Kilometer.
Kilometers.
So if you are changing from centimeter to kilometer, we divide by 100,000 and we get 0.5.
So it's not a 100 divided by.
Come again.
Wait. Oh, okay.
Look at the question over there.
I'm just getting it, sir.
All right.
Yes, sir.
Okay, good. So I've not yet finished. What I'm saying now. L and M are two tracking stations. State in centimeters the distance LM on the map.
Sir, 7 centimeters.
No, count again. From L to M, no. Make sure that you count.
8 centimeter.
Meters.
From L to M,
8
0
centimeters.
is 8, right?
Yes, sir.
It will be 8 centimeters. So this would have given me 8 centimeters. Now, they asked you to calculate the actual distance in kilometers from L to M. Calculate the actual distance in kilometers from L to M. You got 8, right? So 8, how do you come? So the 8 centimeters on the map, what will you do?
Multiply the
Multiply
8
by
times the 50.
You
0.5.
multiply.
8 times the 50,000 and divided by the 100,000.
Exactly. All right. So for me to do that aspect right now, right? For me to do that, I am going to what? No, I need a space here. So what I will do here, right? I would have multiplied the 8 times the 50,000, right? Which give me what?
400,000.
400,000 centimeters. But they want the answer in kilometers. So what will I do?
Divided by
Divide by
100,000.
100,000.
So this one here, right? Divide by what? 100,000.
Which is 4.
4
Right.
Kilometers.
So get to 4
kilometers.
4 kilometers. Yeah.
Sir, excuse me, could you write the number for the question beside it, please?
Which one?
Sorry, the one that you just did.
Oh, you can't see this one. They say, okay, they say calculate the actual distance in kilometers from L to M
Excuse me,
on the island. So that was the question.
Okay, sir, thank you.
Sure. Now,
Sir,
yes,
where the A come from?
come again.
Repeat.
Where where what?
The 8.
No, because remember the 8 is the one we counted from L to M initially. From this one here, the answer we got previously. Remember, we can't look at it. We counted here 1, 2, 3, 4, 5, 6, 7, 8 boxes. So the 8 boxes give me, each box is 1 centimeter. So I got the 8.
Thank you, sir.
You get that? Next,
Yes, sir.
the area of the shaded on the map, right, or the forest reserve by counting the squares. Estimate in centimeter square the area of the total reserve. Right. So we have to count the place them shade, right? Anybody here know how to do the counting in mapping?
Yes, sir.
How do you do the counting?
They're going to put one full.
Come again.
They're going to put one fully shaded.
You count what is fully shaded, right? So let's try that first. We are going to count what is fully shaded. So we are going to count this one here, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Am I right?
Yes,
so I get 12 fully shaded. Now I'm left with 3, 1, 2, 3. So let's say 1, 2, 3, give me 1 and 1.5, right?
Yes,
and
sir.
let's say 1, 2, 3, also give me what? The 3 is 1.5. So 12 plus 1.5, that will give me what? 15.
50
So we are going to see
Yes,
that the answer,
centimeters square.
right? So now, no, we say this answer that be 15 square units. 15 square units, right? Square what? Units.
Sorry, I'm gonna get you.
Sir, could you repeat what you just did?
Okay. I was asked to count the area of the shaded region, right? The shaded forest. So what we did, actually, we counted the boxes which are full. Like, follow me. We counted the boxes which are full, right? So look at it here. So this would have been 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and what? So I count 12. Are you seeing that? Now, the 12 now, with the 12, you have 3 of them here, right? 1, 2, 3 here. Like they have like half and half and half. So that is 1.5. And here to 1, 2, 3. So that's also another 1.5. So I add the 12 plus the 1.5 and I got the 15.
So the small box is represent 1.5.
No, the 3 of them, 1, 2, 3. The another 1, 2, 3. So that means each of them is like half.
Oh, the small box represents half.
Right. So look at it. You see this part here? You see this part here I'm talking about? The 3 sides here and this one here.
I get you.
All right. So when we do that, we get 15 square units. Then the last question, they say that they calculate in kilometers the actual area of the forest, right? I need to calculate the actual what? Area of the what? Forest. So how do I calculate the actual area of the forest now? We counted 15 boxes, right? We need to calculate, okay, we counted 15 boxes, right? So we need to calculate the area for one box in kilometer, right? Let's calculate because they want to answer in kilometer. So look at it. I'm going to draw this. So this is one box. Everybody see that? What is the side of one box? Yeah.
Oh, so sir, if so 15 square units, I go square the 15 unit, then convert that into kilometer, then divide it.
That will be too much work. Look at the last one. Look at this one. You see this one here? You see the one I circled a while ago? Given that 1 kilometer is that 1 centimeter on the map represents how many?
0.5.
0.5, right? It's kilometer. That means this one is 0.5 kilometer, and it's also 0.5 kilometer, right?
0.5.
Everybody understand that? Because it was 500. Remember, it was 500. Am I right? And you divide it by 100, and you get 0.5. So find the area for one box, right?
0.25.
So the area for one box would have been 0.5 times 0.5, which will give me 0.25.
25.
Then the 0.25 now, we multiply this number here by what? 15. So 0.25 times 15 now. Let's work it out and see what we get.
3.75.
3.75.
So the area we are looking for, that be 3.75 or 3.75, right? Kilowatts.
Meters.
Kilometers.
Redo that.
So would it be kilometers square or just
Okay,
kilometers?
no, kilometer square, thank you. Kilometer square.
Yes, so each box represents 0.5.
Come again. Each side represents 0.5 kilometer.
Or each side of the box.
Right. Because remember, no, each side actually is 50,000, right? Centimeter. With the information they gave us previously, 1 to 50,000. Are you seeing that?
Yes, sir.
So if this is 50,000 and divide by 100,000, you get 0.5. And divide it also by 100, you get 0.5. And it's a square. Right, you multiply 0.5 times 0.5, you get that. They get 3.75 kilometers square.
Okay, sir.
All right. All right. So yeah, I can do that. All right.
Thank you, sir.
Next, right? Can we move on?
Yes, sir.
Yes, sir.
So I'm good. Can I clear now?
Yes, sir.
Oh, yes. So quadratic graph. How many of us can see the graph good?
Reason.
All right. So you try as much as possible to see if you can answer the questions on this quadratic graph. All right. Let's see exactly what we can do, right, and see. So they give us a function. Now, when you're doing quadratic graph and you put fx, what does it mean?
Why?
Y. So they say that using the graph, determine the value of y when x is equal to 1, 2. Now look at it. Using the graph, right? Using the graph, wherever you see fy, just remember that wherever you see fy is the same as y. All right. So find the
So you
value
mean
of y
fx?
when x is right. Fx is the same as what? Y. Yes. So find the value of y when x is equal to 2. So we go to x is equal to 2. Where is 2, by the way? We go
Wherever
to
the X is.
we go to 2. Right? Then if I go up, I'll not meet the curve. So I'll go where? I go down. Everybody see that?
Yes, sir.
Then here now I'll come here and go where? Across. Now, what is this figure?
-5.
-5.
Right, so get -5, right?
So, sir, what if I worked it out using the formula, even
No,
though there's a graph?
no, they say use a graph, so they'll mark you wrong. -5.
Sir, we do that, please.
Okay, so they say that find the value of fx, meaning find the value of y when x is equal to 2. So you go to 2, we see where I have 2, then I go down, right? I go down until I meet the curve, then I'll go and read the value. So this is -4. The next one will be -5.
Okay. That's
You're
the way.
welcome.
Oh, you want to go down because you want to meet the curve?
Exactly. If I go up, if I'm at 2, if I go up, there's no curve for me to meet. Are you seeing that? So it's a
Yes,
must
sir.
have to go down.
Okay, sir.
All right. Look at the B. The value of fx when x is equal to -1.5. -1.5. -1.5. Where do I find -1.5?
On the left.
On the left. So we go to -1.5 and we go up, right? You see what I'm doing now? Now this time we realize that now I have to go to the wall. So I have to make sure that when you are doing this, right, I will advise that and use a ruler. Right? You use a what? Ruler. Right. So that at least you get to right.
So sir, when I posit, so like for the first question, when it says x equal 2, you carry it down.
No, because the purpose is to meet the curve. So if I come here, look at, if I come to 2, if I go up, will I meet any curve?
Okay. It's to meet the curve.
The purpose is to meet the curve, right?
Okay.
And -1.5, I can't bring it down. If I bring them down, I don't meet any curve. Are you seeing that? So I have to go where? Up. You see that? Then I will what? I will go this way and try and read the value. What's the value? What do you get?
3.
Is it 3 or 3 point something? Because
3.1.
my is not good. So you guys have to tell me that.
3.1.
3.1, sir.
3.1.
So that means
barely pass the 3.
Sir, can you remove the red thing?
No, yeah, I'm going to read it. No, hold on. I'm going
3.2.
3.2.
Every line is 0.2, no? Every small line is 0.2. Okay, let's see.
3.4.
So every line, listen, every line is 0.2. Every line is 0.2. So I'm seeing it properly now. It have been 3.4. Everybody agree?
Yes, sir.
Sir, do you back over?
Okay, so look at it. $1.5, right? Look, you see that? I'll go until I meet right here. Look, you pass the 3. Are you seeing that?
Yes, sir.
Until this line. Check it out now. You see that? How many lines after 3?
2.
2, right? So each line is 0.2. So if you meet 2, that will be 3.4.
3.4.
You get that?
Yes,
Yes,
sir.
sir.
All right.
Sir, always every small box 0.2.
Okay, so I'll explain to you now. So look at it. You know that this side is 1, right? This side is 1, am I right?
Yes.
So
Sir,
1
you know
over,
where to
hold
stop.
on, 1 over how many small lines? From the 0 to the 1, how many lines do you see?
0.2, yeah, 0.2. 0.2.
So this one, how many small lines we have? We have 5, am I right?
5.
So 1 divided by 5, what do I get?
0.2.
So that's how we got the figure. So if you check it out, this is what 0, 0.2,
Sir, you know
0.4,
where to stop
0.6.
on it.
No. Okay, so when what how do you know where to stop? Wherever, okay, when you come here like this, right? And you are going up, just follow the line until where it stops. It stops right. Look at it. It stops right here. You see that? It stops on that line there. So it when it stops on this line here, you stop. You can't go any further. So this is 3, 3.2, 3.4. You see that?
Sir,
Yes,
explain
sir.
it a little bit more simple.
Yeah.
Which way? Okay, guess what? Okay, you understand that every line is 0.2?
Yes, sir, but so what are the small lines?
No.
What?
Okay, so we have the major line, which is 1. This is 1, 2, 3, 4, 5, right? So 1, 2, then 3, then 4, then 5. The small lines are this small one. Look at it. 1, 2, 3. The little lines between 0 and 1. Or the little lines between what? Between 1 and 2. That's what we call the small lines.
Also, is that keep it the 3.4?
So you when you count here, you came here and you got what? 3. Am I right? Now, with the next line, when you go, the next line is be 0.2 because every line is 0.2. And the next one to meet is what? 3.4. Because only one line is 3.2. Am I right?
Yes, sir.
So if it's 2 lines after 3, what do you get?
3 points.
And you can't go above the curve. When you meet the curve, when you read the curve, you just stop right there. Just like this one here, look at it. Just like this one here, when it came, you stop and it goes direct and got -5. The same thing here. You understand that? Okay, take your time and look at it carefully. Right, because all what I can tell you is that every line is going by 0.2. So if you come here and you are going up, right? Maybe I'll ask if somebody can explain to you better. So we are
Sir,
here, yeah.
Sir, where your shade, right? Is where the lines intersect?
Right. Okay, where the line intersects with the curve, yes.
Okay, I got you.
So wherever the line will meet the curve, so like you are drawing this line, look at it. You see that? Okay, so let's draw this line here now. Wherever this line meets with the what? Curve, that's where you read. You go across and you read it. That makes sense now to you?
Yes, sir. Make more sense to me.
All right. This one. Okay, all right. Thank you. You get it? All right.
The same must always try and meet the curve.
Yes. Okay, next question. The value of x for which fx is equal to 0. What are they asking for? Who can tell me? The value of x for which fx is equal to 0. What are they asking?
Sir, it's asking for the roots or
Value
the
at the
solution for x.
They are asking for the roots or what you call the solution. Thank you. They are looking for the roots or the what? Solution, right? So another thing here is this, they asking for the roots or solution, right? So this one here is the same thing as asking for the roots / the solution. Right. So where do we find the roots? Right here. Everybody see that? And right here. Can somebody tell me what is the what do you see? What is this value here? And what is this value here?
Negative 0.8.
Negative 0.8. Yes, you're right. Negative 0.8, negative 0.8. Yes.
And 3.8.
And 3.8. Thank you very much. So negative 0.8 and what? 3.8. Next question.
Oh,
Tell me.
sir, she count the small lines to get the 8.
Yes. Because
Oh,
on
yes,
the x-axis
on
now,
the
remember on the x-axis now, every small line is 0.1.
Oh, sir, because them they further apart.
Right. So, and look at it, and this one is 10 lines. This one is for 10 lines, right? So 1 divided by 10, we get to a 0.1. You see the difference now? So
Yes,
this one is for x-axis. This one is for the y-axis. Y what? Axis. And this one is for x what? That makes sense?
No, sir.
The value of every small line on the x-axis is 1. So this is 0. Look at it. 0, 0.1,
0.2.
0.3, 0.5. Then what? 6, 7, 8, 9, and 1. Yeah, that's what I'm saying. All right, let's go. Minimum value of fx. How do I find the minimum value of fx?
So that depends on
We
where
need to go to the center of the curve and then.
yeah, the center of the curve.
No, the turning
Depend on
points,
where
right? So
So it would be 1.5.
nope. Okay, no, they say that the minimum value of fx. How do you determine the minimum value? We come right here, look at it, this one. Yeah, we come right here. You see this one here?
At the belly.
The belly, yeah, the belly. We go to the belly and we go and read the value. Right? This is negative 5 point something. Can somebody tell me what is it? Negative 5.3. That's what I'm seeing.
Yes,
Anybody see that?
sir. Yes, sir.
It's not reaching negative 5.4. No, it doesn't reach negative 5.4.
Negative 5.3, sir.
Negative 5.3.
Yes, sir.
Right? Because it have
So
come
it
here.
don't pass 5, sir.
It passed 5.
So about 8.2.
Huh? No, remember that after 5, every line is 0.2. Right? So on the Y, so it passed the first line, it never reached the second line yet. It's in between. Everybody see that? So
Yes,
when you go here like this, well, when you go here and you go across and you watch and you watch and you watch, you realize that it's right what in between that. And that will give you what? Negative 5 point what?
True.
Negative 5.3, right? So negative 5.3. Now, the value of x at which fx is minimum, what are they asking for? The value of x at which fx is minimum. So at the same place, right? We go up. What are they asking for? Who can tell me?
Sir, that's the point and just the point at the x-axis, which is 1.5. It's a
Right,
1.5.
right. We call it the axis of symmetry. Right. So in other words, say the axis for the axis of symmetry. Everybody understand that?
Yes, sir.
So you go here now, right? And this is it. So this, we say this is the axis of symmetry.
The first circle?
Axis of symmetry, symmetry. It's like this, axis of symmetry. So that should have been negative 1.5, right? Because this is a number, right? Right number is 1.1, 1.5. Everybody agree?
Yes, sir.
Yes, sir.
Mm-hmm. Okay.
Sir, so the answer is 0 too. Sir, right?
No,
That's
just 1.5.
Oh, okay.
So this
Because
will be,
the FX.
no,
Now,
that
what
will be
you
the
said.
value of x. The value of x. That's the key point. The value of x is 1.5.
Okay.
Now, so I'm going to do this one now. They say the solution of x squared minus 3x minus 3 is equal to 5. The solution, right? So how do we find the solution of that?
Sir, would you draw a straight line at 5?
We draw, yes, we draw a straight line at 5, right? So what we're going to do is this, we draw a straight line at what? 5, all right? So what we are going to do is this, we go to 5. This
On
is
the y-axis.
then what you do next?
You get the
We go down, right? We go down to read the words, the values, right? So we are going to try a thing. So everybody look at this one now. Go down, read. I took the wrong, I want the arrow. Can somebody read where the arrow is touching for me, please? What do you see?
Zero,
Negative
negative
1.7.
Negative 2.
Yeah,
Negative 1.7.
Negative 1.7 and what? And 4.7, am I right?
Yes, sir.
Right. No, okay, so remember
Oh,
you
yeah,
come
the
here now, you draw the
1.7.
line, at this line at 5, right? When you draw the line at 5 now, you take your ruler and go down and figure out where the line is cut on the x-axis, right? So if you check it out, this is negative 1.1, negative 1.5, 6 and 7, right? When you come here now, after the 4, you have 4.
So the line this small line in the mean 2 again.
No, on the x, on the x is different from the y. On the x-axis, that's what I did over here. Look at it. I did it here for you to see. On the x-axis, every small line is 0.1. Whilst on the y-axis, every small line is 0.2.
Because a line on the x-axis smaller and further upward, like closer. So that's why I'm count it by 2 and 3 y-axis, like further upward, count by 1, say 1, 2, 3, 4, 5, and go up.
But you can even try it in count 1, 0, 1, 2, 3, 4, and 2. This and see how many boxes inside between that, and that will give you that. Okay, so here the answer we are looking for would have been negative 1.7 and what?
4.7.
4.17. Okay, guys, exactly 11 o'clock. We have to close off. Yeah. So wherever we reach, God will see you through tomorrow. Cool, everyone.
sir.
Yeah, we are not going to
Yes,
see it after 11. Right, we're not going to stay after 11 at all. So
Bedtime.
bedtime, exactly. You need to rest and feel fresh for tomorrow. Whatever comes your way, you just deal with it. All right. And remember that I have to come, as some of this place may have to come to have the class because there's no light in my area right now. Okay. Where am I? So
Sir,
yes.
do you think any construction will be coming?
We have been debating on that. To me, it seems no. And I'm going to be optimistic that it's no, because I don't want it to come, because we never teach it. No, seriously, there was no construction last year. There was no construction last 2 years, right?
See?
Yes, sir.
Construction.
Right. So I don't think they are going to bring construction. Right.
They're probably them dengue this year. You don't know.
Yeah, that's why I'm hoping that they don't bring it, because we never get the time actually to teach that per se, the way I wanted it to teach it. I only taught it one time in my class or 2 times. That is it. But but my students who do online class with me, I couldn't teach them at all because I don't have the software to teach it online.
So CSEC cheeky, you know.
I know. All right, let's go. Where am I? The interval on the domain, right? The interval on the domain for which your fx is less than what? -3. So what you do here, right? I'll look for -3. I'll look for 3, right? So somebody should mute the mic. Who is that? All right. Mute your mic, right? We'll soon finish. Don't worry. By 11 o'clock, we're out of this place. So we come to -3, which is this, right? And we draw the line here. Then we go up. What number is this? What number am I seeing here?
3.
3. And we go up here. What number are we seeing here?
0.
So it's between 0 and what? 0 and 3. So you are going to put here the interval here that be 0 less than equals to x less than equals to 3. Because they say you should write as interval, right? You are writing it as what? Interval.
Sir, you forgot the underline under the less than.
Come again.
You forgot to underline the greater than sign.
Oh yeah, you're right. So that being this and that, all right? Are we clear?
Yes, sir.
Okay, let's see what
Sir,
is
hold
in.
on.
Yeah.
Sir, do that over again, please.
Okay.
I'll be sure on it.
Okay, so what to do, they say that the interval on the domain for which fx is less than -3. So we go to -3, just like we did for the 5, you see? Just like we did for the 5, but this time we are doing for -3, you understand? So you go to -3 and draw the line at -3 like this. You see that? Then you go up now on the x now. When you go on the x, you get 3 here. And when you go on the x here, we get 0. Follow?
Yes, sir.
All right. Okay, so we clear?
Sir, angular elevation and depression, them not bring that number for exam.
I am not sure. You can't CXC, trust me. You can't trust them for nothing. All right. you,
Sure, when I get bearing.
Just like
yeah,
ask
of
that,
course you can
sir,
get
bearing.
bearing.
Yeah, bearings
Sir,
are
will I
much
get bearing?
better.
Joke can't make sense.
Sir, I hear that we're getting linear too.
And maybe you can get linear programming, but it could be in the form of it can make it easier for you where you only write the equations, right? Or they give you the graph, interpret from the graph, right? So it all depends on what comes, right? So
Sir,
let me
but bearings easy.
no, it depends if you know what you are doing.
All right.
All right. Okay, so let's hope that if POB never add, maybe this is good. All right. All right, let's go. No, you have to try and just calm down. That's why I just don't want anybody to panic, right? Okay, so remember that for quadratic graph, right? They could also give us for quadratic graph, they can give us the graph and you have to complete it. And you draw the graph itself and you do whatever. Everybody agree with me? Can you guys hear me?
Yes, sir. Yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
No.
sir, we're good.
Nah,
Yes, sir.
all right. I'm saying that most likely, right? They could give you what? The table for you to what? To complete it. Then after you complete that, they will give you the what? To plot it on the graph paper, and they ask you for the same questions we were doing a while ago. The equation of answer symmetry, the minimum value, the values of the same thing. All right. So we can skip this. Can we skip it?
Yes, sir.
Oh, then this is where I want to stress myself a little bit. What do we see here?
Vector, sir. What's about this now?
Right, so vector, you can't escape vector tomorrow. For sure, vector and circuit theorem, then matrices, then maybe linear programming, you can't escape them. Right, those things are the
What is
back.
linear programming? Sir,
Don't
what is
worry.
linear programming?
If you don't know it, there's no need for you to know it now. Right, just work with what you know. Linear programming is when they give you like inequality questions. For example, the inequality questions, yeah.
Okay, that.
But they put it in words. Okay, can we try this quickly, everybody?
Yes, sir.
Yes, sir.
Okay, somebody read it and rock and roll. Can somebody read it?
Yeah, what topic is that? Linear or vector?
No, the diagram below, yeah. Can you see the screen?
Yes, sir.
Can one of you read it, no?
So I can't read.
The diagram below shows a triangle OPQ in which OP equals 3U and OQ equals B. Q is the midpoint of OR and M is the midpoint of PQ. L is a point on OP such that OL equals 2/3 times OP. Let's say write in terms of U and B an expression for LM and PR.
All right. So the first question they asked me is to find what is what? L what?
LM.
LM. Right. So let's go and find LM now. So LM is this. We have to draw this, right? We draw a line from L to M. Everybody see that?
Yes, sir.
Then what you do here, you want to find LM. Now, so for me to find LM right here, right? What I am going to do is LM LM will be equals to LP. So I move from L to LP plus PM. Now remember, no, if I want to find LM, I have to go around. I move from L to P, then P to what? And by now everybody know that, right?
Yes, sir.
Now, so what I am going to do here is this. I know what is LP. LP is U, but I don't know what is PM. Do I know what is PM?
No.
No, so we have to find PM. Now, anybody can tell me how do I find PM?
Sir, I go find the OP and then I go find the OM.
OP and OM. Okay, you realize that they say Q is a midpoint. They tell me that Q is a midpoint of what? OR, and M is a midpoint of what? PQ. So that
Okay,
means
they
saying the
put,
M, that
UM.
means saying the M will divide into what? PQ into 2 equal parts. Now it means therefore for me to find PM, I need to find PQ first, right? So even though I was not asked to find what? PQ, I need PQ in order to get what? PM, right? So I'm going to find PQ. If everyone understand that, so let's find PQ. From PQ, we move from P to O, then
P
O,
to O
then
to Q.
Q, right? So P to O, then what? O to what?
O to Q.
All right. So let's say PO now. For me to find PO, I go where? I go the opposite
Down.
direction. Down. The arrow was going up, but I'm going where? Down.
Down.
When I go down, it will be negative what? Negative U plus OQ is V. Right. So therefore, I can say that a PM, this side would have been, here would have been half 3U plus V, and this side is going to be half 3U plus V. Why? Because they say M is the midpoint. Everybody understand that?
Yes, sir.
Now, so after we establish that now, right? We can easily say now we can say that if I want to find LM, LM will be U, LM is going to be LP plus PM. LP will give me U, PM will give me half negative 3U plus V, right? So I want to put this one nicely. So I put this over 1, then I put the LCM. My LCM for this would have been 2. 1 go to 2, give me 2 times. So 2 times U give me 2U. Plus 2 going to 2 give me 1 time. 1 time this give me plus negative 3U plus V. All right. Everybody see that?
Yes, sir.
Yes, sir.
Then we put it together now. So if for me to get my answer now, I'm going to get 2U minus 3U give me negative U plus V divided by 2. That's my answer.
For the LM, right?
Come again. For
For the
LM, right?
LM.
For the LM. So indirectly, we needed to find PQ first before we can find what? LM. You follow? You follow what's happening?
Yes, sir.
Sir.
Sir, you can explain why the 3U negative?
Okay. Because the arrow was going up. You see, look at the arrow. You see the arrow was going up. This was 2U and this was U, right? You see that the arrow was going up, but now we were going down. We are going from P to O. We are going the opposite direction. If you are going the opposite direction, it will be negative. But if you are going the same direction, that means positive.
Oh, okay.
You get it?
Sir?
Yes.
Yes.
If we did the multiplication first, we'd still get by the same answer, right? Like if we did the half time whatever was
Yeah. You get by the same results. Yes. But normally that will be too much work. So I leave it that I do it the simplest way. But nothing wrong with that.
Okay.
All right, where are we? PR. How do you find PR?
PQ plus QR.
PR. So from P to R, you have to draw a line, right? We draw a line from where? P to R. Everybody see that?
Yes, sir.
Yes, sir.
Right. So for me to do this, PR will be equals to what? PR will equal to PO plus what? Which direction you went?
Plus OR.
Below.
Which direction you want to go?
Below.
PO plus OR.
Okay, PO. Okay, that's fine. PO plus what? OR. So PO would have been negative 3U, right? Plus what? They say Q is a midpoint, right? So if here is V, this is also going to be V. Everyone understand that? If this one is V, here is going to be V. So we get what? 2 what?
2V.
2V, yeah.
So why I said it's V?
No, because they say Q is a midpoint. I was given the information, right? That the Q is a midpoint of OR and M is a midpoint of PQ. So if Q is a midpoint, if from O to Q is V and the Q is a midpoint, that means from Q to R also it should be V. We get that?
Yes, sir.
All right. Next. Then they say I should prove that what? I should prove that LM are what?
Collinear.
Collinear, meaning straight line, right? How do I prove that a line is collinear? So here we have to draw a line from L. We are drawing a line from L, right? From L, going to the M, going to the what? R. Right? So, first of all, for you to prove that it's collinear, we have to come LMR, right? We say that M is a common point, right? M is a common point. M is a common point, right? The common point. Right. Now, after I tell that M is a common because say you move from L to M, then M towards R, right? Now I'm going to compare LM now. LM with LR. So I know what is LM already. So I'm going to find what is LR. So LR, how do we find LR now? We know that this answer is what? LM is
It's
LM is no.
3U, yeah.
What do you get for LM?
Negative U plus
Negative U plus V over 2. Now, so if I want to find LR, right? LR now is going to be, let's find LR. We move from
LO.
LO, right? We can go from L to O. LO plus O what?
OR.
OR. So what we have? It have been negative 2U, am I right? Plus what? 2V.
2V.
All right. So listen to what I'm going to do here, everybody. Watch what I'm going to do. Maybe that can help somebody.
Sir,
This one here,
put it
this
over
one,
one and work it
this
out.
one, this one, the same thing as 1/2, right? Bracket U plus V. Everybody see that? And this
Yes,
one,
sir.
this one have been, this one is same thing as 2 brackets negative U plus V. See if you see that.
Yeah, the factorize it.
Right, you factorize it, right, and just make it that way. Then what happened? This one is a common factor. Are you seeing that? So what do you realize now? You compare the LM and the what? LR, right? You compare the small side with the big one. So LM with the what? LR. How many times what do you do to LM to get LR?
You times it by 4.
You times it by 4, right? You times it by 4. Or you say 2 divided by 0.5. 2 divided by 0.5 will give you 4. So you are going to say that LR is equal to 4 times of LM. We say therefore they are parallel, right? Therefore they are parallel. They are parallel. If they are parallel, they have the same gradients. They have the same gradients, right? Gradients. Now, you say therefore L, M, R are collinear. So how do you determine if 3 points are collinear? Rule number 1, they have to have the same common points, right? Rule number 1, they have to have the same common points. Rule number 2, they have to have a common factor. But how do you know that they have a common factor? They have to be multiple of one another. So realize that the LM is 4 times of LM. What's the common factor here? Negative U plus V, negative U plus is the common factor. So we prove that LMR are what? Collinear. So the only thing you need to prove are these 3 things: multiple of one another, and they have a common factor. Common point and a common factor, and that should have indicated that. Don't. All right. As I said, right? Don't get panic, guys. Just go in and do your thing. Any questions so far?
Yes, sir.
Yeah, what's the question?
Sir, like for the formula, like the cosine rule formula, would that be given to us in the examination, or we have to memorize it?
Okay, so the cosine rule, you are going to get it in front of the what?
Paper.
You're going to get it in front of the paper, right? So you just, when you get the paper, what to do,
The formulas are.
the formulas, most of the formulas you need will be there, but not all of them. So some of them you are required to know them. All right.
Which ones are those, sir? I'm not sure.
Like the cosine, the sine, and those stuff.
Then the area, they'll give you the area them too.
Sir,
Yeah.
The perimeter.
sir, like the length of line and the midpoint of a line, you would have to know those.
Yes, you have to know them because they're not giving you not even one of them.
So you're sure?
The cosine rule they'll give us, right, sir?
Cosine rule, yeah, cosine rule, they'll give you cosine rule, they'll give you sine rule, but midpoint of a line, they're not going to give you midpoint of a line, they're not going to give you equation of a line. They're
So
not
the trigonometry formula, sir. The other one where you find the angle.
Yeah, they'll give you.
With the a square.
Yeah, cosine rule.
Yeah, cosine.
You get a cosine rule, they get a sine rule, yes. All right. Guys, don't get panic. Just go and do your thing. You'll be surprised. Okay. So
feel like it's easy.
No, I believe that it's not going to be.
What?
I believe that it's not going to be easy. it's
Sir,
not
I'm
going to
feel
be
like it a bit
difficult. I don't think it's going to be that difficult. But if you don't practice, it will pose a challenge for you.
Yeah, that's actually.
Right. So I'm hoping for the best. That's all I can say.
Sir, a quick question, sir. If an average math teacher can tell all of these things that you're doing now, how must an average student do that?
Come again.
Sir, if an average teacher can tell all of these things or explain certain things without using what should be the
So what do I go?
For
Sir,
the
They
angle
ask
PTR,
PTR,
is
right?
for
75.
the same segment,
Let me see. Angry PTR,
75.
PTR. Yes, man. That is 75. Yes, you're correct. So that will be what? Angles in the same segment, right? 75 degrees. Angles in the same what?
Segment.
So,
Yes, sir.
it's two,
No, because,
2
okay,
marks per question.
2
One
marks
for
per
the answer
question.
and the theorem.
Right. One for the answer and one for the theorem. So if you know the answer and don't know the theorem, you still still get some marks. All right, let's go. Next one. Angle TPQ.
sir, I go minus the
No, let me
180
see.
from
Where is it
75.
again? TPQ. They want this angle, right?
Sir,
Is it the cyclic quadrilateral, sir? Or
Hold
no?
on. No, I'm trying to figure it out from
Yes,
different
sir.
angle.
I see it, sir.
Yes, it's a cyclic quadrilateral, but you have to apply.
So you have to,
Now, let's see what happened. Oh, okay, yeah, we can still apply.
So
It's
you'd
valid.
have to minus 60 from 180.
Right. So this one here, all this angle here would have been 120.
120.
Because I'm going to straight add up to 180. Now, this plus this should also be 180. Because that should be
That would be 60.
cyclic quadrilateral. So this should be 60, yes.
Yes, sir.
oh,
Right? So first of all, you have to justify though that angle on a straight line add up to what? 180.
180.
Then when you get 180, that means
180.
here there'll be, if you're 60, here there'll be what? 120. And if it's 120, here there'll be what?
60 to give the 180.
80. Because opposite angles in a cyclic
Cyclic
quadrilateral
quadrilateral 180.
Exactly. All right. After we're done that too bad. Look here. You'll be surprised to know that tomorrow the exam is going to be much easier than what you think. All right. I'm just being positive. Next. The obtuse angle PO what?
R.
Of the circle. So PO. Okay. So you have to put this one here, right? Everybody see that?
Sir, that 90.
So would I know, sir, that was RO, sir?
No, they never put it, but you have to put. That's what they said. Obtuse angle PO. So there's no O. The only O here would have been in middle of this thing.
Okay.
Middle of the circle.
Middle of the circle here, because they never put O, but you have to go and put that O. Right. And they want you to find this angle. So that's where we have to use our brain now and see how we can get that one. But it's still easy.
So that would be 45?
No.
No.
Sir, with a 90. Well,
No.
the diameter.
No, remember that this is angle at the circumference, right? And this will be angle at the what?
Center.
Right. And what's the relation between angle at the circumference and angle at the center?
Oh, the add up to
At the center is double.
90 degrees.
Double. So that'd be what? 2 times 4.
75.
You see, because angle at the center, because that's what they look at it. So you do realize that they say POR, right? So when you come like this should have been angle at the circumference and it will be angle at the what? Center. Is it 2 marks? It's 6 marks. That is it. There we go. So after all, it wasn't that bad. Am I right?
Yes, sir. You're good, man.
Sir, it was fine.
Okay, so guys, I wish you guys all the best for the tomorrow exams. Ensure that you pack your stuff tonight. Make sure that your calculator is working properly. Ensure that your calculator is in degree, right?
So we check it again.
Check and see, put in sine 90 degrees, right? Sine 90.
Sir, when you put in that, you must get 1.
Yes, if you don't get one, you have to change the mode. But you ask somebody to help you to change the mode.
Sir, boss a bad prayer before you go in.
Yeah, you want to boss player?
Yeah, you are for prayer.
Yes, sir. You are prayer man. You are prayer warrior.
On to Bobby.
Matthew, don't take me on tonight, please.
Okay, let us pray. Let us pray. Hold on. Let me stop the